Well, welcome back to our podcast, The Robot Queen Meets Dr. T. And in episode 1, we talked about how we came into robotics and somehow how we didn't leave. So we still are here. And then today in episode 2, we wanted to talk about what happened after, actually. So the glorious, chaotic, why is the robot moving there? So we want to talk about our first automation failures, because failures is what we experience are crucial in learning, in the learning process.
Yeah, that's like I think we learn most of um, the good things about in automation when the failure happened.
But you always remember the robot crashing or a robot doesn't move in the suspected way. So yeah, people always assume that robotics is about or the robotics career is about the success, but in reality, it starts with, let's say, creative misinterpretation of coordinate systems. That's at least my experience or my main failure point. So in robotics, in the 3D world, you have a lot of coordinate frames you're working with. So the robot moves in different kinds of world frames. And if you don't define that in the correct way, or if you forget to specify the right coordinate frame, it can happen that the robot moves the exact opposite position you expect it to be. So, for example, a set frame can look upside down in one frame, but in the other frame, it could be 180 degrees in the different directions. So if you, for example, define a different tool frame with a wrong orientation, the robot doesn't move from downwards upwards, but in the opposite way and crashes the table or the wall. So yeah, this is, let's say, a really aha moment you remember forever.
Yeah, like you might like learn, yeah, you have to do that, but you just realize that you didn't when you see happening, you're like, oh, I forgot that.
Yeah, so but that's the interesting part, I think, in robotics. So you immediately get feedback of the things which went wrong. So you have a feedback loop instantaneously. And yeah, for the next time you remember to check before you run the robot program.
Yes.
So, and this also leads to another failure, that you doesn't check your program in manual mode, just go quickly to the automatic mode because you think, I have programmed it so many times, I know exactly what the robot is gonna be doing. But then you realize it's
Something, no, it's not.
something is off. Yeah, this will not be good.
Yeah, no, like I remember once I have a few because when I was learning, I kind of learned practicing. Like we like I did have a short training, but we like I learned hands-on. Like that's the robot. We have to program it. So a lot of things happening. I remember once I was calibrating the tool, and when you have to kind of teach the 4 points there. And okay, by theory, it's fine. Like you just jog the robots for the 4 points and everything is fine. But then I didn't check the speed of the robot and it was not really slow. So I just point the robot, press play, and the robot went really through the conveyor. I was lucky that the tool that we're calibrating was like a needle, so it was really, really tiny. So it didn't make like a big hole the conveyor because it was like a belt. So the damage was not that bad. Like I didn't damage the conveyor. I just damaged the tool because it was so sharp that when I went straight down, I was like, oh God. And then I remember my supervisor, he was like, Vanessa, we forgot that you need to slow down the robot to teach, to get really close to it. And I was like, oh, I just forgot. And they'd be like, yeah, like you saw that, like, yeah, I can do it. But it happened. So after that, I never ever forgot
Yeah.
now to change the speed when I'm calibrating the tool, and it was good. I learned my lesson. The other one about it, as you said, like you just press play without manual mode. That was a funny one because we programmed the robot, myself and another colleague. So we kind of, okay, we know that what the robot's doing, so it's fine, right? But I changed one position and I didn't touch up the position. I just changed the values in the axis because back then I was not aware of all the, how you say again, the not coordinate system,
Yeah.
configuration of the robot, like because the axis can be in the same I'll say degree, but in different configuration. So could be face down or the other way around.
Yeah.
And I didn't know that day. Like for me, it was like, yeah, once you have the position for the axis, it would be fine. So I just changed the axis, one axis only, not the whole position configuration. And then in my mind, it's like, yeah, the program was running fine. So we just pressed play in auto. We didn't test that in manual. And the first position for, well, the majority of the robots will move and join as the high speed as you have in your program. So our one was really high speed because of the application. So the robot just moved kind of all the way around like this.
Yeah,
To
that's
do the
very
movement
scary.
that's supposed to be just like something really small.
Yeah.
It's kind of flip over. And then I was like, what? So I was holding the teach pen and I pressed the stop in the middle like of the flip. I was just lucky that didn't have anything in the cell that the robot could crash.
Yeah.
And then we like, what's going on? And then I was like, no, I just changed one number. And then we checked there because the number I changed supposed to be negative, not positive. But because I didn't touch up the position, I just changed a value. I was like, okay, lesson learned. First of all, you have to learn this because each robot has one, and you cannot just change the axis like this. That was one lesson. And the second one, never ever test your robot in auto after
Yeah.
a change.
Yes.
And then even though like back then I did have some experience, I think I have like 7 months already because we programmed that robot. And but that's the problem. You feel confident that like you wrote the program, nothing's gonna happen, and then you press play already now too. And then like it doesn't matter even now after 7 years. If I program the robot, it doesn't matter what I'm doing. I will always test in manual mode first, and then go to auto with the speed a little lower, and then I speed up. I never go full auto again because like I learned my lesson that day, and could be much worse because if you had something in the cell, the robot would crash like straight away.
Yeah, this is especially tricky if you have a longer program and you change a lot of things incrementally and you get bored of always running through the whole program in manual mode because you need to hold the buttons as a safety reason. So yeah, it's tricky, but you need to stay
because that's how you avoid accidents, you know.
Exactly.
I remember one project that I did around 3 years ago. For me it was weird, but you know, a client asked for, I recommend that's not the way. He wanted the PLC to control all the movements from the robot, but not like each movement, but like I should write pick and place applications and turn the robot some like blocks of code, and then the PLC would choose which block to run.
Yeah, just triggers
the trigger there in the background. And then I try to explain to my clients, was like, well, that's really risky because something happened with that the communication, and the PLC sends the wrong command, the robot would crash. But if I write the code in a sequence, then would not crash because there is a ways to control that.
Yeah.
He was not happy. He wants the full control. I was like, okay, but there are risks. We should not test in full speed. He did not believe me. He's like, no, my team from the PLC, they're ready. They test this over and over online, the simulation. I was like,
Yeah.
okay. I was like, that's your risk. First time running the PLC code, the robot should go inside a container to get the product. But first, it should read like with the camera, where is the product, and then go to grab it. For some reason, of course, it missed the first part, or I don't know what happened. It went to grab the product. It didn't go to the second part that closed the gripper and move out. No, it went once and then went another one because
yeah.
the arm was like 2 meters long, so it did have space to go even more. So in the second time, I just pressed a stop, but it crashed a little bit inside the products. And I was like, that's not the way we test. You should test in manual mode because to avoid this. Then back and forth, I asked the team, the PLC team, I was like, have you tested this before? No, we haven't done this yet. We're just testing now. I was like, we're gonna crash a lot of times if you send the wrong signal, the robot would not know that's wrong, like unless we write around it. Yeah. And they did not want me to make the robot make decisions. The only way the robot to stop is to crash. I was like, we're gonna crash a lot of times here. We cannot do this. Anyway, we spent 6 months doing the way the manager wanted because that's the way he wanted. And back then I was just starting automation. It was another, I would say, not failure, but was a lesson that you need to explain to a client. And then if you don't agree, I should have stepped out of the project because it's like, that's the way it's gonna give a nightmare even to troubleshoot later on, because once the PLC send that signal, the robot will read, and then the PLC would send this signal after signal. So to troubleshoot, you would not see which signal. What happened that moment, because the PLC probably is like 3 steps ahead already, and you don't know in which step was what happened, was the error. And but in their mind, because it worked in simulation, it should work in real life. And I was like, guys, it's not like that. I always test in manual mode for a reason, because if it crash, you can break the robot. I believe I never broke a robot. It's really hard, but you can break the tool or that's the worst part.
I mean, you could also harm a person. Yeah, it's very dangerous. This machine-to-machine communication, you don't have any delays in simulation, and you have to keep that in mind. That's totally true. The real systems always behave a bit different than the simulated models.
And I think it's just sometimes people just get too confident that what you can do, and there where the mistakes happened. And I've seen that over and over, and I was like, guys, it doesn't matter if you have 10 years, 20 years, you don't skip the steps. Most important, safety. Safety needs to be done and the right way. And when you explain to people, they were like, no, that's not it. I have one client once that was like, we need to test the robot full speed to see the cycle time. But the cell was not ready. There was no guards around the robot, and was a really big industrial robot. And I said, until you have something to protect the robot against people to get close, we're not running 100%. If you do that, I'm going to step outside, because what happened here going to be your responsibility. And he didn't understand. It was like, look at the gripper. It's like a plate and
Mm-hmm.
the guards
Which,
facing
yeah,
down, but it's a plate. So it's some, and it was like the high of the
your
neck. So if
throat.
someone was
Yeah.
walking by and for some reason the robot
Mm,
passed through it, it's just gonna lose your head. Like is not that you're gonna knock someone. No, you're gonna cut someone neck
yeah.
there. You
Mm,
need to test. You need some safety around it, and
yeah.
then people would talk. No, we can do this. We can bypass that. And I always say I don't bypass the safety like this. No,
Yeah.
for testing, and of course, while you're testing, you have to bypass a few things, but in a control environment. So
Yeah.
you protect the
Mm,
robot so people would not get close. Once people are close to that, working around, no testing at all. Like when before I opened my business, I used to work with a machine builder, and we have so many procedures. It's like today we're gonna test, so there is no electrician around, there is no mechanical people around. We've you got like if even though there is no fence, we're gonna cover around with some protection, like even people not getting around, and never work alone. So if you see someone
yeah.
walking by, press stop, and it doesn't
Yeah.
matter. It doesn't
Yeah.
matter because that's how mistakes happened. And
Exactly.
some people, especially some clients, don't understand like what's going on. Like
Mm,
once, I remember that too. Um, Actually another lesson, like another I would say failure. We didn't add to the code like safe, not safety checks, but error checks. Like let's say if something happened, the robot would not do something, and
okay.
this robot should go inside a mold machine, collect the part, and place in a conveyor on the top of a conveyor.
Mm-hmm.
But the thing is, we never thought that, at least me, I, I was my failure there, that we need to check the possibility of the operator go inside and manually close the door because we just check
Yeah.
inputs and outputs.
Yes.
Like
Yeah.
the door is closed, the door is open, happy you go, send the robot in, collect the part, out, close
Yeah.
the door, happy ever, every, easy
So
peasy,
you
how did they say?
so you didn't check
But
the status of the door. Yeah. Okay.
again, we never
Yeah.
check like again and again after open and close
Okay.
the
Yeah.
door
Yeah.
of the cell.
Yeah.
So, and then, well, swear to God, never occurred to me or even the other people on the team. And like, it was really great lesson that day because it did happen. We
Mm-hmm.
stopped, like, we tested in house for like months, before
Yeah.
sending the application to the client. And then we went there, we did the whole installation, worked fine for a week. But then for some reason, the mold machine has a problem. The operator stopped the production in middle of
Mm-hmm.
there.
Yeah.
So when he stopped there, I don't know how he did it, but the robot already had the signal that the door was open. So he stopped kind of in the middle. So it was, I would say, two failures there. That it should
Yeah.
not stop middle cycle, should finish the cycle and then continue. And second thing, it should check again the door, and it was not on the prompt. So
Yeah.
the person got in, uh, was something with the mold machine. He removed the material manually, closed the door to restart the cycle, and press reset.
Yeah.
But as the robot had that signal that the machine was open and ready to pick, it went with the full speed and it crashed and
The door.
of course the robot didn't break, but it damaged a little bit the tool and the pipes. Well, I think was some liquid. I'm not sure it was a coolant or it was water. I think something like that. And it broke got loose one of the pipes and was water or liquid everywhere. So
Yeah.
they called us and we got there, myself and my boss, and he looked at like, we never thought about that, did we? And I was like, no, but never. And like, of course we were wrong because you never know what the operator can do. So you have to
Yeah.
have that in the program. But it was honestly, we never thought someone would
Yeah. Yeah.
really stop in the middle of the cycle. But again, two failures there because we didn't have, and now that's something I also add in all my programs. Like, okay, you can stop the machine, if not IE stop, of course, to get inside the cell after the cycle stops. And then,
Yeah.
of course, check that input like 3 or 4 times before going in. And yeah, it was a lot of lessons for one failure.
Yeah, very interesting because the the thing about testing is also that you always test foreseeable um, situations, right? It's hard to think of a situation which is not the normal case. And that is actually what you need to test when you test the robot program. So what kind of all things could happen when it's not the normal process?
Yes,
And
yes.
that's very hard for the human brain actually to compose those states or
Yeah,
non.
and especially if you're not really 100% on that application, that process. Yeah, of
Yeah,
course, you're gonna have some ideas like, yeah, like if the mold machine stops, if the conveyor stops, I don't know, if the power goes
yeah,
down, but like you'd never account to the human error. And then after that, we kind of almost changed the procedure for all the other projects, and it was great because you have to consider the operator because they're gonna do crazy things that
yeah.
you never ever gonna think about it. Like, why do something like
Yeah,
that?
yeah, yeah. I think it is really tricky to uh, to consider all the system state variables in the robot program. So if you have a binary sensor, you have basically um, 4 states of the systems, and you add another binary sensor, and it just adds up incrementally. And yeah, the robot itself, it has unlimited possible states. So that is very tricky to define those states and to always check, okay, this combination of sensors or states could lead to this, and this combination could lead to this. And this is actually something where AI methods can help now, that you compose those different kinds of states and do the logic or the safety logic at least.
And get a better solution. Yeah, like I always recommend to my clients, and they don't understand like why you need to test so long. It was like, yeah, like sometimes we spend like a week programming the robot, but we need at least, and I say at least 1 week of testing in the client environment.
I say that too. And at least 1 week of testing.
At least 1 week, like, is the minimal. And for their, like, no, but it's a matter, it's money. We don't need if it's working. That I was like, yeah, the machine is working in the environment we program, like, but we are feeding the machine by hand sometimes, or we are sitting there watching the machine. So we are responsible for the machine that time you're programming. So you know that what you shouldn't do. Yeah. But the operator that is tired or doing 3, 4 other things, and he have to go there and check a few things, he'd be like, oh my goodness, we were not expecting that. So the testing week, and I say at least one, but really the dream is like a month testing in the client environment. So then when you go home, you don't come back for at least a year. But they don't understand that concept. In their mind, it's a waste of time. And like, yeah, we need to be there looking at the operating, using the machine to see what they usually do or what they possibly gonna do, so then we can fix it in the program.
Yeah.
And they don't understand. They'll be like, no, but it's a waste of time. Like I start saying no, and that was something that I learned with my business, because I do believe we need to test. But I think one client didn't want to test, and then it was like, well, we just wrote the program for one product only. Like I cannot guarantee it's gonna work for your 20 products. We need to test, because this robot is a collaborative robot, is different is not the same. Like if you put there something really heavy for the payload, will act differently. So we need to test. No, like he would test on his own. He didn't want to, and I agree, I believe was one of my favorite sayings, like yes to him and agree with the project, because of course when he tests, it worked I think for 10 products, but then 2 or 3 it didn't work. And then he was blaming me that the program didn't work. And I was like, okay, that's the test phase for. And after that, I said no for 2 other clients because they didn't want to test. They just want like, yeah, you write the program, the robot is running, and here we go back home. And I was like, no, there's a lot of responsibility here because we prepare for the scenario you sent me. That's the robot picking in place or welding or, cameras in most of applications are pick in place.
Yeah.
For that scenario, perfect scenario, at the robot will receive the part and place the part. You're not reacting with the environment, like what the operator could do, what it cannot do.
Yeah. Yeah,
and
especially the physical characteristics. Somewhere the gripper can grip it and hold the parts, but if it's heavier and yeah, the physics, the real
everything.
life,
for example, let's say that the feed machine that's feeding that robot, does it always have the products in the same way? Because sometimes you don't know, like it happened before. The machine, the infeed machine was kind of closing the boxes and sending to the robot. But the average there, after 20 boxes, something would happen with the machine. They have to reset it, but it was not the robot. Again, their program was the machine itself, the feed machine. You cannot control that. And then the operator have to be checking that every single time. But we didn't know, I didn't know that information, that some, random boxes would come open without the tape, because the machine didn't have a way to check if it was with the tape or not.
Yeah, okay. Well, okay, that's, you can.
So how we would know that? And then it would start crashing or losing the box. And the importance of testing, because again, you don't know what could happen, like this machine. Then we have to add something in the robot. I have to add to see if it fail the vacuum, then do something else or just stop the robot. But again, that is things you wouldn't know unless you test it, and they would not give you all the information. But like, that's the way you learn, that's the way you test. And I've seen a lot of robot programmers that with years of experience facing the same problem. Like they wrote like an amazing program on the robot, but then when we go on site to test, the environment is not even close what they told us. Like one was amazing because it was a robot in the top of AGV, so the AGV should move, collect the parts, bring it back, put in the conveyor, and there we go, right? Yes, we got there. The floor was not flat, but was not in an angle all the way, because if it's just up or down, you just adjust that and have you go. No, it was around, like it was every position of the AGV would be in a different angle.
Yeah.
But nobody from the project thought that they should go there before checking for the AGV. I was just programming the robot. But it was like, guys, that would affect the camera too, because when we calibrate the camera, the robot is facing away, but then if you start changing that angle, we need to adjust our calculations to that. So we spent probably another 2 months adjusting the calculation, because again, the client floor was not what they sent to us.
Yeah.
or even the containers was not what they sent. But that's the failures we learn. Like I believe every project that is a failure, uh, or even a challenge that you face that you never thought before. But with the programming, oh my goodness, so many. Uh,
Yeah, there are. It, so many came just into my mind. Yeah, like you said, the velocity, the zone parameter. If you forget the zone to set it right, then the robot is just moving to the other direction and doesn't stop at the point. These are just the easy ones. Yeah, we got deeper in logic
yeah, but
and
the thing is,
safety.
we want to say, and it's normal. Like
It's normal.
it's
Exactly.
our daily life. So you the thing is, you have to learn with that, because
Yeah.
the next project will
And it's
gonna be something else.
and it's totally not embarrassing to make failures in
No,
programming.
no, no, that's
They're
totally
foundational.
normal. It's just like, okay, we learned that. One thing I used to do when I was working in a team, because now when I go, it's usually myself and maybe one or two operators. But before I opened my business, when I was working in a company, what we usually do as a programmers is like we share. Okay, so I made this mistake, guys. Next time, just remember we do this way
Yeah,
or that way,
yeah,
or have you tried this way? So we even have, I even started back then, it was really nice, like a arrows log. So we would describe the arrow like that happened here, or
yeah,
even the print screen of the teach pendant. And that's what I tried. That's what we worked. That's not what not worked. And then everyone start popping, adding to this Excel file. I think it was an Excel file. I don't remember now. And it
yeah,
was great because sometimes we're facing the same error or we did the same thing, and people will
mistake.
learn
Mm,
together. And because when I started, it was like, oh my goodness, I was so scared that the robot wouldn't move the first time, and it didn't. And I was like, what have I done wrong here?
yeah,
And like I got the ditch pendant, and now like I press the motors on, nothing happened. It's like I did everything I supposed to do. The robot is on. Well, I just forgot to change from auto to manual, because in the training center, we always get the robot in manual mode for safety. It's never in auto. So
yeah,
when you
yeah,
go to the project in real life, there is a chance that that robot is already in auto, and you need to remember to just to change.
yeah.
And I spent like a really good 10 minutes, like, Jesus, what am I forgetting? Like, I should just press play and
But
go.
this is also a tricky part. If you have the robot in auto mode and nothing happens, nothing moves, then you think, the robot is switched off or something. But in real life, he's maybe waiting for a sensor
Or
signal
something.
or something, and this can be also a tricky part. So you need to think, why is it not moving? What did I forget? And this is also where yeah, mistakes happen if you try to move or put your hand into the
And
cell.
then, yeah, that's the thing you have to be aware,
Yeah.
because if it's waiting for a sensor and you flag that sensor, the robot
Yes,
would move.
yeah, and suddenly it moves. Yeah. So yeah, always remember, if the robot doesn't move, then switch to manual mode again,
Mode first.
and
No,
then
I remember
test.
one client that I was helping remotely. He scheduled the whole day to help him troubleshoot the robot. Send me a message. He's like, "Are you sure it's in the robot itself?" No, Vanessa, I think we need to change position. The robot it stopped here. Some of is not working, and like he knew how to change manual to auto, so he would change manual, play the whole code, but when it was about to grip the part, would not move. It would stop completely, and then that was the problem of waiting for a signal.
Yeah.
So I went through the things, and then I'm like, wait a minute, what is this input that's waiting for? But the thing is, it was not me who wrote the code. So please, guys and girls, comment your IO in your code.
Yeah.
That make lives for everyone better,
Yeah.
easier. So of course there was nothing there, like it was just like our input 8 or whatever it was, and that's it.
Yeah.
You figure out what it was. Of course, he didn't have at least an IO list of inputs and outputs because it was a 15 years old project. So there we go, and back and forth. Like went through the phone. Okay, let's try to figure out if you can see something in the teach pendant. So we gonna spend probably half an hour trying to figure out was that input number 8 because was waiting for that. Well, was the sensor in the gripper to saying that the gripper was fully open.
Okay.
Amazing. Once we figured that out, I could explain to him, well, that means your gripper is a problem with one of the cables there. It's or got loose or something because that's the input. He's like, yeah, Vanessa, hold on a minute. I was like, is the robot in manual? He's like, yeah, manual now. I'm gonna power it off. So he gonna power it off because was a cable, electrical cable. So need to be twice safe. Great that I have really good clients. So he went there. The cable was loose. He tied up all them just to be sure. Turn it on again. Play the from the start. Worked. But we spent more than 30 minutes to figure out one input what was because who wrote the code didn't mind to add any information about that input. And we have to go forward and back. I was like, okay, what could be in this part of the program that the robot is checking right now? I was like, yeah, should be something in the gripper. So we went through a few steps and then it was like, yeah, that's the sensor. That's to say that the gripper is fully open. But yeah, like sometimes, of course, you can imagine if that robot was in auto and he was there changing something in the gripper, the gripper would close with him beside it, and that's really dangerous. So you have to explain sometimes, because sometimes I heard clients like, well, but if the person is inside, the robot should be off. Well, like you don't know who programmed that robot because if that person didn't really add the safe to it, it doesn't matter. And some people don't have that knowledge because in their mind, the robot should know. And it was like, well, we're not there yet. Maybe with the humanoids in the future in AI. But right now, if you don't really program your robot to identify the safety and stop when you open a door or cross a light curtain, the robot is still moving and is still going to do something. And like I seen that before. And in one project, I went, they hired me just to program the robot. So everything was supposed to be ready when I got there. I programmed the robot and I said, like, we should test the e-stops, the machines. But not just the robot, because the robot will stop the robot, but we need to see if they are connected to the main safety, and then to see if that's going to stop the robot. And they were like, no, Vanessa, we can test. So with a lot of me asking, please, 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 being like, I was so annoying.
Annoying and annoyed.
Oh, I'm back again. Sorry, it cut again. Problem. Okay, I just changed the Wi-Fi here. So come back to the client. So after I annoy them for half a day, it's like, please, it's just gonna cost us 10 minutes. And they did test. So all the stops was controlling the robot. Once they press the stop, the robot would stop. Great. But nobody thought to test the e-stop from the robot controlling the machine. In my mind, I was like, yeah, well, it should be two ways, right? If they're controlling the robot, the e-stop in the teach pendant should control the machine. And of course not, because the electrician thought that was not important. Like why the robot, like you would stop. So once we were testing the machine and I was holding the teach pendant, because again, if something happened, I can stop the robot straight away, even though it's in auto. And something happened in the machine, like the conveyors didn't stop where they should stop, and the parts start falling off of the conveyor. So they just asked, can you just stop? And then I pressed the stop, but the robot was already in pause, so it doesn't matter for the robot. But the old cell keep moving, and I was like, no guys, my e-stop doesn't do anything. The other guy went to another e-stop from the machine and did not stop. So in the end, the e-stops were connecting just to stop the robot itself, not the whole machine.
The other parts, okay.
And then people were like, what's going on? Because who wrote whatever they're testing, they bypassed the safety for testing. And then the e-stop wouldn't do anything unless stopping the robot, because I really asked to test. It was like, we need to understand before we go to auto, even though the speed is like 10%, 20%, is still auto. Like we need to know that, like I can stop here, the teach panel, of course, they are already connected to the robot. But if you see something from behind that I'm not seeing from where I am, because again, the robot's in the middle of the cell and we outside, there are things you might not be able to see it, but you need to be able to press a stop and stop everything. And it was not. And people were just like, oh my God, this was like, guys, we need to check safety. And sometimes it's like, you sound like an annoyed person ever. Oh my goodness, why I have to do this? It was like, it's step by step. They are there for a reason. And but the failures, like you learn with your failures, but at least I learned with my failures, and I add that now as like, okay, this was happened before, what we do to not happen again, you know, like just really learn.
So what advice would we give?
Well, first of all, don't be afraid to fail. To failure, to fail. Don't be afraid. Sorry, don't be afraid to fail, because that means you're trying. And that's normal. Things gonna happen every day. Things that you're not expected. The best thing is learn with your mistakes, and if you want, write it down. Sometimes that's how I did when I started. Things was like, okay, that message start with me, like what does that mean? It was like, yeah, I forgot to put the robot in manual, or we forgot like a sensor is not working. Like most of it, your robot will give error, or even though the calibration, remember to bring it down the speed before calibrate. Make notes, or well, that's the way I kind of remember. But some people take pictures, a way that you will remember those mistakes, because we're gonna make that every day. I still am making mistakes by the day, but like the way now is just I learn quicker, and then I can solve those problems quicker, and then it's just getting better and better. But that's how you get better. Don't be afraid, and don't be shy to communicate that, because that mistake could be fixed when you're saying something. And because if you hide that, don't worry, people will know that was you.
I would add, if your programming or if your cell works perfectly on the first try, you definitely forgot to test something.
Yeah, you did something wrong. You forgot to remove any bypasses. That's not normal. But like we test that remotely. We simulate that for a week. It doesn't matter. It doesn't supposed to work everything right in the first try. Forget about unless this is the third or fourth machine you're just replicating, then maybe there is a really 5% of chance that will work. And why I'm saying that, because I did that before. A client already had 2 machines, so he bought 2 more machines the same way. In his mind, it's just copy and paste the program, press play, and there you go. 1 day for each machine. I was like, well, that's not how that works.
No.
It's not just copy and paste. It's not a laptop that like you still have to install things. You still have to master and calibrate the robot.
Yeah.
And but in his mind, no, it's just copy and paste. It should work, right? So I used to have a boss, and he's like, "It's the same. It's exactly the same, but different." That's what he used to
Yeah,
say. Yeah, it's
exactly.
exactly the same, Vanessa, but different. Like it's always different. Like, and one thing I explained to my client, and maybe I don't know many people, if you know that, or if you don't, please leave in the comments here. I would like to know. The robots are not exactly the same, even though they're the same brand, the same type, the same model. Why? Because they're not 3D printed. And even though they're 3D printed, they're not exactly in the same position of the encoder. So the
Yeah.
0, 0 position for this robot is not the same for this one, that one, or the other one. And then for the simulation to transfer to the robot is the same thing. Of course, the softwares are getting better and better, and probably in the future you would not face this problem. But the encoders are not exactly the same. So, for example, those machines, they're replicas from other machines, so same exactly measures and everything. So we place the robots the same position of the two. One worked okay, we just have to adjust 2, 3 positions. The other one was completely out.
Yeah.
And it's like, why? It's getting singularity every single time. And then the client couldn't understand. And it was like, well, because the encoders of this robot, we need to move a little bit for that way. So then we avoid singularity. And it was like, no, but we have to be in this exactly same place because we are copying the program. But yeah, they're not exactly the same, even
Yeah.
though they're the same brand, same model, made by the same factory. They're not 100% exactly the same. So there is no copy and paste in automation, at least now. Maybe in the future they would get better.
Yeah.
But yeah, so we used to joke this a lot. I believe it's still a joke in automation. Yeah, this is exactly the same, but
But
different.
different.
Yeah, don't expect you just copy and paste the cell and it would work fine. Sometimes it even a nightmare because it was working fine in the other cell. So why this one is not working?
Yeah. Yeah.
That happened with me. It was like, why this robot is getting so many singularities if it's exactly the same positions and programs and it's in the same place? Because now we have to move 5 centimeters away just to avoid singularities. It doesn't make sense. Yeah, it's that robot, those encoders, and you just need to learn and get better.
Yeah. Yeah. Well, this was our episode 2 of Making Mistakes. I hope or we hope our failures made your day better a bit.
Feel more confident now that make mistakes is normal, means
Yeah.
you're trying something.
Yeah, and it would be interesting if you also share your mistakes or the mistake
Yeah,
you
leave in the
remember the
comments
most.
here. Yeah, something that you learn so we can learn too.
Yes, sharing is caring.
Yes, love that.
So yeah, hopefully see you at the next episode when we meet again.
Yes, and like if you want to know something, you can leave in the comments also for next episode. Like we're trying this here, and it's been amazing sharing our experience, and I hope you like it too.
Thank you. Bye.
Bye. Cheers.